Another set of questions on the bonding and structure topic, and as always the link to the questions in the description of the video if you want to try them first. Okay, so make a start. So ionic bond is the electrostatic attraction between oppositely charged ions. Moving on to the dot and cross diagram now for barium oxide. So starting with the barium ion, I've gone for crosses for the electrons. So 8 electrons in the outer shell, 2 plus charge, and you can have an empty outer shell there if you want. And moving on to the oxide ion, so oxygen's in group 6, so I need 6 of a different type of electron, so open circles, and there's the 2 electrons from the barium, 2 minus charge. Moving on to the next part, so the first thing we've got to do is work out how many moles of barium oxide we've got, so mass over mR, so we've got that many moles of barium oxide. So the moles of barium 2 plus ion is going to be exactly the same because the formula is BaO. So for every mole of barium oxide, we've got a mole of barium 2 plus ions. So to turn that into a number of barium 2 plus ions, we multiply the moles by Avogadro's number, which in standard form into 3 significant figures, 5.89 times 10 to the 21. And the last part of this question, so we're told barium chloride soluble in water. Compare the electrical conductivities of solid and aqueous barium chloride. So the key thing here is the type of particles involved. It's not electrons, it's ions that are carrying the charge. So in the solid state, the ions are all held in the lattice, they can't move, so it's a poor electrical conductor. However, if you dissolve it in water, the ions are now free to move, they're mobile, and so it has good electrical conductivity when aqueous. Moving on to the next question, so we've got to state the shape and the bond angle around the carbon atom in the alkyl group. So obviously this is the alkyl group here, so we'll just look at this carbon. So what have we got around here? We've got 4 electron regions, they're all bonding regions, so we've got equal repulsion, and the shape associated with that is tetrahedral. The bond angle around there will be 109.5 degrees, and there's the explanation: 4 bonding regions, equal repulsion. And finally the bond angle around the oxygen in this COH bond. So you'll notice I've put the electrons into the bonds. So the carbon, let's say, has this cross here. The oxygen in the middle has got 6 valence electrons, so one of them has gone into this bond here, another one's gone into the OH bond, so it's obviously got 2 lone pairs. So that open circle there belongs to that hydrogen. So what have we got? We've got 4 electron regions, but we've got 2 lone pairs within there. So we knock off 5 degrees from the starting angle of 109.5 degrees, which gives us an angle of 104.5 degrees. So that starting angle was 109.5 from your 4 electron regions. You've got extra repulsion from those 2 lone pairs, and that takes 5 degrees off the angle.